My report is on the tide pool ecosystem in Acadia National Park on Mount Desert Island, which is in Maine. Mount Desert Island is located on the Gulf of Maine, so further up north. Before I begin, I will go over some abiotic and biotic factors of this ecosystem. A tide pool is not the same as a regular ocean environment because there are many other different factors involved, one of which is tides. In Maine, tides can get up to 10 feet in average, but sometimes during a king tide, it can get up to 15 feet. These organisms need to be able to withstand the strain of being out of water for up to 6 or more hours at a time. Temperature is also a big factor as well. Because it's so cold in Maine, the animals need to be able to withstand the cold, but also they need to be able to withstand water heating up in their little pool. Average ocean temperature in late June is about 60 degrees Fahrenheit. It can get warmer, but on average it's 60 degrees. However, in the tide pool, things heat up because the water isn't exactly flowing and it's just standing there. So, when I was at my camp, an average temperature for tide pools that they could get up to and safely still function is about the lower 70s. Air temperature plays a factor as well, for animals are frequently out of the water at low tide. Average air temperature in late June is about in the upper 70s to lower 80s. Salinity also plays a major factor as well. Because the water sits in the tide pool without any sort of circulation, and because it evaporates while standing there, the salinity can get higher than in the ocean. Average salinity is on average about 33 to 35 parts per thousand. However, like I said before, the salinity in the tide pool increases from the water evaporating. The average salinity in the tide pool is about 36 parts per thousand. Maine has a very interesting geology, especially on the coast. Most beaches there are not sandy, with the exception of Sand Beach in Acadia National Park. Therefore, the soil type is not sand, it's actually granite. Oxygen also plays a major part in the ecosystem of a tide pool. Oxygen is about 6 to 8 milligrams a liter. Now that we went over some abiotic factors, let's move on to the actual ecosystem. Before I move on to the tide pool, here is a list of all the organisms I included. First, we have our periwinkles, Littorina littorea, Littorina obtusata, and Littorina saxatilis. We have our sea stars, which include Asterias vulgaris and Leptosterias littoralis. Then we have our whelk, which includes Nucella lapillus. Then we have our limpets, which are Patella aspera and Patella vulgata. Then we have our amphipoda, which, if you are a local, is called a scud. Then we have our mussel and our barnacle. The mussel is Mytilus edulis, and the barnacle is Ballonus ballanoides. Finally, we have our crabs, Pagurus acadianus, or our hermit crab, Cancer auratus, our rock crab, and Cancer pagurus, or the Jonah crab. Let's move to the tide pool now. Welcome to our tide pool. As you can see, the sun is barely rising and it is at low tide. There are two things I forgot to mention, and they are vitally important to this ecosystem, for they are our primary consumers. The first one is our phytoplankton. These plankton take energy from the sun and convert it so animals, such as really anything, can eat them. Second, we forgot our green algae and our brown algae. This is called Ulva lactuca, or sea lettuce, and everyone enjoys eating this. This one is called Ascophyllum nodosum. This is a brown algae, and I didn't draw it very well, but these have little bubble rafts that float along the surface, just so it can float up and get energy from our sun. Let's begin. As you may have noticed, it is low tide, so the water still has yet to come up. A bunch of our organisms, namely some periwinkles, some barnacles, some limpets, and a whelk, are out of the water and closed up as tight as possible, so the water inside does not dry out. In the water, you can see that there are some creatures that are open, including this barnacle. Barnacles eat phytoplankton, using little hand-like feathery things that come out of the barnacle and draw the plankton inside. Another consumer of this plankton is something called a scud, or a side swimmer. These are amphipods related to shrimp. They also eat sea lettuce, as this one is doing right now. Another creature that eats phytoplankton is the blue mussel. Blue mussels, like our barnacle, have these feathery arms that shoot out and grab onto the plankton and filter out the water. They also act as filters, for they clean contaminants out of the water. Periwinkles, such as this one and this one, as well as these, also eat sea lettuce. So basically, if ever you see sea lettuce, don't expect it to last long, for everybody eats it. Our sun has risen quite a bit more, and also has the water. It hasn't quite entered the tide pool yet, but creatures that hadn't been photosynthesizing overnight are now photosynthesizing. Those creatures that photosynthesize are also eaten by the secondary consumers. Water is now coming from over the side into the tide pool. And as you can see, some organisms are underwater that were not underwater before. These barnacles can now start eating the plankton. I have talked a lot about primary consumers being eaten by secondary consumers. So let me talk about secondary consumers being eaten by other secondary consumers. Seemingly insignificant whelk, or dogwinkle, eats quite a bit. It acts as our carnivore extraordinaire. This creature eats our blue mussel, our plankton, our limpets, and our periwinkles. Both of our sea stars, such as the northern rock star and the slender green star, also eat quite a bit as well. They eat our mussels, our limpets, and our periwinkles. Our rock crab and our Jonah crab also eat quite a bit. They act as omnivores, for they eat sea lettuce, as well as our whelk, our limpet, let's see, here's a limpet, and our side swimmers. hermit crabs don't eat as much, but they do eat a lot. They eat limpets, and there's one right here, and our algae. A cool fact about crabs and hermit crabs is that they also eat each other. They are not picky when it comes to their food, as long as they have something to eat. It is now almost high tide. As you can see, most of these creatures are covered, except for a stray limpet and a few barnacles. These barnacles and all these creatures can now start feeding. As nice as it would be, this environment does not remain untouched by man. We frequently take organisms such as our crabs, our sea lettuce, and the filter feeders, like these mussels, for our own consumption purposes. Also, when we wear sunscreen and go into these pools, the chemicals on our skin leach into the pool, and our filter feeders cannot keep up. We are also careless with our trash, so it ends up in the water. The food chain is now disrupted. We have no more primary consumers, so our secondary consumers begin to die. After that, everything just begins to collapse. There is no more food left for these creatures to eat off of. All that is left is a stagnant pool filled with garbage and oil that is continuously being washed out to sea and also being washed back in by the ocean. It is a bitter truth, but there are things we can do to prevent this from happening. There are things we can do to preserve this and leave it for others to enjoy for years to come.